Yes, as Kyle said, my name's Ben, and this is a kind of preview of a talk I'll be doing next week at reInvent. So reInvent is the annual AWS customer conference that happens in Las Vegas every year. It's about 60,000 customers that come and listen to talks with multiple experts from all over the world at AWS, both people that work at AWS and people that are building, customers and heroes alike. And the CTO of Amazon usually does the keynote on the final day, on the Thursday. I'll be talking later on that day, and this is my talk. It's Advanced Serverless Workflow Patterns and Best Practices. Now, I've had to leave out some of the launches that we'll be talking about next week because they haven't launched yet. So apart from that, this is more or less the talk that will be happening. So nice to meet you. My name's Ben, as I said. I'm a principal developer advocate for serverless at AWS. I've been with AWS for about 5 years now, but I'm actually from Brighton. I went to Sussex University about 20 years ago with my friend Tim here, and we're still friends, just about, aren't we, Tim? Yeah. And so this is the first time I've ever got to do a talk that I could walk to directly from my house. So that's a new experience for me. I really enjoyed that today. The most important piece of information here is really my email address, my contact info. So if there's any questions which I don't answer at the end of this talk, then please do reach out to me there. I'm not going to be showing lots of links throughout the talk, just one here, which I'll show again at the end. So from here, you have lots of downloadable templates in infrastructure as code, like Terraform, SAM, CDK, CloudFormation. We have lots of blog posts about some of the features and functions that I'll be talking about. Many videos from beginner to advanced, some really good workshops as well, so you can start getting your hands on some of the services I'll talk about, and hundreds of code samples that you can download and try some of the patterns that I'll be showing you today as well. So as I said, I've been with AWS for about 5 years, and over that time, I've kind of specialized in this service called AWS Step Functions. And Step Functions is a service for building out serverless workflows. And I found that when you build with workflows all the time, you tend to think of every problem in terms of a workflow. So I even do all of my slide agendas as a workflow now. And this is what I'll be talking about tonight. I'll be talking about why I think you should use step functions for your next project, and why I think you should start with step functions for every project, unless there's a good reason not to. Talk about the different workflow types that you can use when you're building with step functions. So there's 2 modes that you can run it in. That's standard and express. And I'll spend a lot of time talking about how you can optimize for cost when you're building with step functions. I know that's important to many developers, and it should be as well. Developers, especially when you're building with cloud services, should be thinking about cost for every decision that you make. I'll talk a lot about some patterns that you can implement with step functions, building with workflows, patterns for building applications that can handle vast scale, and patterns for managing and handling failures as well. And really, this talk is all about giving you the tools that you need to deliver value to your customers, to make apps that are reliable and resilient to faults and failures, that are scalable, simple to understand, simple to build, I hope, and quick to build as well. So I was explaining this earlier to Bettina, is it? Yes, so this is how I think of what is serverless at AWS. Everything these days seems to come out with a serverless version. At reInvent next week, there'll probably be a serverless version of many more products, right? So when everything is serverless, it's hard to define what serverless is. I think it's 10 years to the day or to the week that Lambda was first announced, actually. And we've come a long way. So this is how I think of serverless, as a kind of pyramid of managed services. So at the bottom, you have services such as EC2 that are very customizable, that let you build all sorts of different applications, but they're not managed, right? Not as much. As you step up your pyramid, you get more and more managed services, or more and more serverless. And at the top of that pyramid, you have things like Lambda and App Runner. And when you're building applications in the cloud, you're relying on these managed services. You're pulling them together in various ways, and you're sending data from one service to another in the form of things like events, messages, queues, topics, APIs. So the challenge that arises when you're building with serverless applications that comprise of multiple AWS services, which are all kind of loosely decoupled with lots of different ways of passing data from one to the other, is how do you then understand how your application is held together? How do you inspect? How do you track? How do you operate? How do you understand what it is you've built when it's so loosely decoupled? And this is why step functions is such a great tool. Is anyone already using serverless in production? About a third of the room. Okay. Is anyone already using step functions? Same people. Okay, cool. So this will be interesting. This is an advanced talk for step functions, 400 level talk, but we'll bring you with us. We'll go slow at the beginning here. This next few slides will explain to you what step functions is. So it's a service for building workflows that are serverless. Here you can see I have on the left a kind of drawer of various actions that I can use in my workflow. Now, these can be things like putting something in a database, invoking a Lambda function, starting a batch job, and I select that action and I drag it in to my design view. And then I can arrange that with decisional logic, choices, branches, if statements, loops. I can try and catch errors. And then I can double click on any one of those actions and I can configure that with this editable form on the other side of the page here. Now, this is pay per use. It's entirely serverless, so there's two different payment models, which I'll go into. It scales automatically, so you really don't have to think about the scale that you need this workflow to operate at. You just send requests to it, and it should handle it. It's fully managed. It has this neat drag and drop interface, which I think is one of the best interfaces in the AWS console, actually. But of course, you can export this as code. It's a JSON code called ASL, Amazon States Language. And it's essentially a syntax built in JSON that allows you to drop your workflow into your infrastructure as code templates. You can then commit that to your Git repositories. You can share that with other developers on your team, make pull requests to it, and you're building, build that into your pipeline, and there you're building your workflows with infrastructure as code. Now, here's the magic bit, right? It integrates with over 220 other AWS services. And it does that by using the AWS SDK for each of those services. So every service, more or less, has an SDK with actions for that service, maybe get DynamoDB item. Well, that's a selectable action that you can drag in and configure. And it has access to over 11,000 of those actions. So step functions is the kind of one service to rule them all on AWS because it allows you to orchestrate every other action into these workflows. And so that's why I think you should start with step functions when you build your next serverless application. Has anyone already tried using Lambda to build something? AWS Lambda. Okay, that's about half the room. So Lambda is a service for running code, compute service for running code in response to events. And as I said, Lambda was launched about 10 years ago. It was a kind of revolutionary idea that you could just quickly throw some code up in the cloud, let it run, and then it will take care of scaling for you. So if you have a workload that needs lots of requests all at the same time, all of a sudden you have a spiky bit of traffic, you can send those requests to your Lambda function. It will spin up multiple instances of that Lambda function, run that little bit of code, and then spin them all back down, ready for the next time you need it. That's more or less Lambda. So if you wanted to use Lambda to retrieve an item from a DynamoDB table, this is a table, it's a non-relational database, very quick to look things up and set things to with a key value pair. This is what you'd have to do to just get an item from DynamoDB. So that's quite small, isn't it? But I'll help you out. So first you have to bring in the SDK to use DynamoDB, the AWS SDK. Then you have to bring in the doc client so you can interface nicely with DynamoDB, so you can marshal and unmarshal data. Then you have to set up a params object with things like the name of the table, the partition key, the sort key. Then you have to set up your function. So here I'm using the doc client to use the get item action with that param. I'm returning a promise. I put that inside a try catch statement. I return the error. And then finally, I get to my exports function. Now, this is something that every Lambda function needs. It tells the Lambda function where to start executing code. And it has something called an event object and a context object. You need to learn all about what those two things are, okay? Then once you know that, you can start writing your exports function. You can put in a wait statement to make a synchronous call to this function to get something from DynamoDB, return any errors, stringify the response, and there in that just 20 lines of code and probably about 6 weeks understanding and reading what Lambda does, you've returned an item from a DynamoDB table. Great. You could also do that in step functions, and it looks like this, right? It's just get item, DynamoDB, exactly the same action being performed, almost zero code. You'd still have to have this params object because it needs to know what the table name is and what the partition key and the sort key is. But these two things are doing exactly the same thing. So imagine coming back to this workload in a week, a day, or a month's time. You've been context switching, you've been building other things. Which one of these are you going to more easily understand and reason about and be able to continue extending? With my workflow version, I can still configure my retry logic. I can still catch any more errors and send them downstream to a queue that I can process later. And this is not just what it looks like in a PowerPoint diagram. This is actually how it looks in the service, right? So I log into my console or in my IDE, because there's plugins for your IDE as well. This is exactly how it looks. Then I start sending executions to my workflow, right? I start running it. Now with step functions, you have this single pane of glass that lets you examine every single execution. Every single time you started that workflow, you can see when it failed, when it succeeded, and you can double click on any one of them, and you can look at the different steps that were in that workflow and see exactly where it failed and see the error message. Now, these are things that are quite difficult to do with a serverless application that's spread out across multiple services, right? Imagine a workflow with many, many services with DynamoDB tables, Lambda functions, queues, topics, messages, events. You can build that with a workflow, double tap into it and understand exactly the route that your workload took, or you can build that without a workflow. And who knows, you have to start building dashboards, you have to start using some third party, which there's some very successful third parties out there that are solving this problem. Or you can just use step functions. What you can also do with step functions is you can click on any execution and see what the data looked like before it entered the step and what it looked like when it left the step. So you can kind of trace your data as it passed through your application. Again, these are things that are not easy to do with serverless applications that are spread across lots of different services. Okay, we're going to go back to our Lambda function version because this is a kind of trap that customers walk into all the time when they start building with Lambda. In my Lambda version that I had before, let's say I did use those 20 lines of code and it's running great because it's still scaling in line with requests, right? It's still probably handling everything I can throw at it. So then I get more requests from the business for this little microservice to do more things. And now I get asked, can you make it create and update and delete things on your DynamoDB table as well? Can you build access to that with an API gateway? So let's put a URL in front of my Lambda function so I can invoke it with a REST or a curl or an HTTP call. Very common pattern here is an HTTP to Lambda to a database, right? And this is what customers tend to do because they build something that works in Lambda, then they need to access it, so they put API gateway in front of it. And before you know it, you've got yourself into a difficult situation here because what you have is a Lambda function that's allowed to do lots of different things on your database, regardless of which one of those things it needs to do. It's allowed to do those things. So this is not a very good secure function. It's quite loosely permissed here. You also have to configure it with timeout limits, with memory allocation. These are things that will change the cost of your function, right? What you also have to do here is you're routing every single request, regardless of what it is, with that asterisk, every request is going to your Lambda function. So you have to add some code in your Lambda function to say what we're going to do. We're going to create, update, delete. Well, it depends what that inbound request looked like as to which one of those code blocks we jump to. This is what lots of people will tell you to do. This is a good step. Split that function out into 3 separate functions, one for each one of those actions. So I have one to create, one to update, one to delete. What does this help me with? Well, now each one of those functions is only able to do that one thing. So my application is already a lot more secure. I've also now used API Gateway to decide which one of those functions to invoke based on that request, right? I'm not forwarding everything on API gateway is deciding that. So I've probably stripped out a bunch of routing code in order to do that. Also, I can configure each one of these functions with a more appropriate timeout limitation, memory allocation, so it's probably costing me less as well. So what's the issue? Well, maybe nothing. Lots of people stop here. This is okay. But what we find sometimes is that now you have 3 functions. Imagine this across hundreds of Lambda functions, right? Each function has the same or very similar 20 lines of code. It starts to get very difficult to understand where your application falls down, where to debug, how it's held together. This is the first pattern I want to show you that you could use to build a REST CRUD-based API. So this is API gateway, so you can authorize and authenticate HTTP calls directly to a step functions workflow. And the first step in that workflow is a choice state, which says, based on this inbound thing that started me, what action should I perform? Should I get, put, post, or patch? And then it will run that branch directly on DynamoDB. It's not spinning up any Lambda function here. It runs it directly on DynamoDB, and then it exits. So we built this. The reason we built this is because we had this application that we built for reInvent of 3 years ago called Serverless Espresso. Has anybody heard somewhere of some blog post or something? 2, okay, 3. The Serverless Espresso is an application built by the Serverless Developer Advocate team, me and about 4 other people, to give customers an idea of a real production-ready serverless application that they can use in the expo hall at reInvent. And what it was, it allows you to order a cup of coffee from your mobile phone. So you walk up to a booth, you scan a QR code, it loads a menu on your phone, you select what you want, that gets sent back into the system, a barista sees the menu and they manage your order, make your coffee, and it updates your phone to let you know it's ready. We ran this at reInvent a couple of years ago, and we did, I think, 3,000 orders in the 3 days that we were there. And we had this little microservice here called the Order Manager Service, which was basically a REST CRUD API, right? So we had API gateway going to our Lambda function, and our Lambda function would sometimes do something with a database, or sometimes it would do something with some other service. And it worked, but there were some problems, right? Our application needed to run in real time because there were real people there waiting to get their order notification. And we had some weird latency issues. We had some performance issues, and we found it really difficult to find out where those issues were. So once we got through reInvent, we rebuilt the whole thing as a workflow. This is the version 2. You can see there's only one Lambda function in here now, and all that does is it sanitizes the order. So it checks that the thing that's been ordered actually exists on the menu, because it's a conference full of developers and they were trying to get naughty words up on the screen, right? So we had to constantly code around little tricks that people were trying to do, which was quite fun, really. So this is what we have for version 2. Serverless Espresso in the last 2 years has been all over the world now. This year, I think it's done 66 events. It's done 50,000 orders, I think, and it'll be back at reInvent this year. It was in the keynote last year for the CTO of Amazon was talking about it. And it's all powered by this little workflow, right, that just scales. Once it's built, it just works. We never had to touch it again. So we chose to run that workflow as an express workflow for reasons I'm going to go into now. So this is all about how, this next section is all about how you can think for cost when you're building serverless applications. And I'm going to talk specifically about step functions, but this applies to every service really on AWS. There's always ways you can optimize for cost. So with step functions, there's 2 modes of running your workflow. You have a standard workflow and you have an express workflow, and there's some very important differences. So a standard workflow can run for up to 1 year. It's asynchronous, so you start it off, you won't get the response unless you poll that response by some other means. It has an exactly once execution model, so when you invoke it with a given payload, you can be sure that payload will only run that workflow once, won't get any duplicates. Then we've got our express workflow, which has a much higher throughput. So it transitions through these steps in single-digit milliseconds normally. It's more cost-effective, totally different billing model. It has an at least once execution, so that it can get duplicates. It's synchronous and asynchronous. So you can invoke it with an API call, and that API can hang around and wait for the response and return that, which is why we run that in the previous slide here. This is why we ran it as an express workflow. Faster and synchronous. So that's why we run it that way, essentially. Now, here's the main difference, though. It can only run for up to 5 minutes. So if your workload takes longer than 5 minutes, it will just time out and you've lost that, right? You'll have to try again. So here's a workflow that I created to kind of simulate a simple e-commerce platform. And you have things on here like adding an order to an SQS queue, then polling DynamoDB to check that that order's been processed. Then we notify by putting a topic onto an SNS topic. Then we do some more polling to check that that payment's been made. And then we update some inventory with some Lambda functions. Don't have to worry too much about what that workflow doing. It's an e-commerce workflow. It's real. It does some stuff. We sent some dummy data to it. So what I did was I ran it 1,000 times as a standard workflow and 1,000 times as an express workflow. And I created a CloudWatch dashboard to show you the results. So they took similar amount of time to complete. The express workflow was a bit quicker. It's not that interesting. This bit's interesting though. Standard workflow for 1,000 executions costs 42 cents, whereas the express costs 1 cent. It's exactly the same workflow doing exactly the same thing. One is saved as standard, one is saved as express. There's an asterisk there because standard workflows has a free tier. So I'm assuming we've gone past our free tier. I want to show you how we worked out the cost so I can prove to you that that's real, right? So standard workflows are really simple to cost out. It depends how many state transitions, so how many steps in your workflow. That's what you pay for. And it costs 2.5 cents for 1,000 state transitions, okay? So here's my workflow. I have 17 state transitions along the happy path, and I run it 1,000 times. So to get the overall price, I do 17 times 0.025. That's 42 cents. Easy enough. Express workflows, not quite as easy. So express workflows is all about how long that workflow takes to complete. Doesn't really matter how many state transitions it has. It's how long did it take to complete to the nearest 100 milliseconds, and how much memory did it need to complete as well. So let's work this out. I'm trying to debate how much detail to go into on this bit because it confuses me every time I do it, but we'll give it a go. So essentially what we want to get is the execution cost and add that to the duration cost, times that by the number of requests, right? Now the duration cost is not just how long it takes, it's how long it takes for a given memory allocation. Here's where it gets kind of frustrating. This is taken from the AWS pricing page. This is the memory allocation that the step function service allocates to your workflow. So this is based on how big the input payload is that it needs to process and how big your workflow is. And this is not something you can configure, it's just given to it. And it goes up in 64 megabyte increments. If your workflow is not huge, it'll probably be this number here for the first 100 milliseconds for the first 1,000 gigabyte hours. Don't worry too much, back to the board. So this is what it comes out to, right? I just add those two together and times by the number of times I ran it, which is 1,000, that's 1 cent. The point is, when you extrapolate this out over 1 million executions, you go from $420 to $12.77. And when you plot them together, they start to get different really quickly. And again, this is exactly the same workflow definition. They're doing exactly the same thing. We only introduced express workflows 2 years ago, maybe 3 years ago. People didn't even know it exists. They still don't know it exists. So people have this conception that step functions is very expensive. And they have this conception about other various AWS services because mostly people are not aware of the new features that are constantly being launched to try and help with all of these different challenges, right? So this is how I want to, through step functions is how I want to kind of explain that. So why would you ever run your workflow as a standard workflow when Express is so much cheaper? Well, if it takes more than 5 minutes, sorry, you have to run it as a standard workflow. If it requires exactly once execution, again, you'll need to run it as a standard workflow. But there's things you can do. Like I said before, there's lots of features that are out there to help you with this. So the takeaway from this is whatever you're building with currently, look into it, see what's coming out next week, see what came out the year before. I'm sure there's something you can do to optimize for cost. Here's a pattern you can use here. if you have to run this as a standard workflow, I can use both, right? I can nest one workflow inside the other. So here I have this polling loop. Let's say that sometimes that takes more than 5 minutes. Maybe there's a person involved in that, right? And if that takes more than 5 minutes, I have to run that as a standard workflow. So what I'm going to do is I'm going to take the pieces of this workflow that do run under 5 minutes, and I'm going to just save that as a separate Express workflow and embed that in. So that's these Lambda functions here. Strip that out, save as an Express workflow, and just call that from my parent workflow. And I won't spend lots of time on this. The thing to know is that I've gone down from 17 state transitions to 14, and now my parent workflow costs 30 cents and not 42. I add the cost of the two together. Well, my Express workflow is tiny. It doesn't even affect the overall cost. The overall cost of running this now as a combined thing is now 30 cents. And once again, I now have the power to run this for 1 year because I'm using the features of both of those workflows together. Okay, step lifecycle. I'm not going to go into lots of detail about this, but the point here really is that there's lots of controls you can use with step functions to manage the payload as it moves through the state, right? So maybe I will go into detail. I do quite like this. So this is what an object, a data object looks like as it enters your state. For example, simple JSON object. This is available to me in my step or my state. And this is a context object. So this is information about the execution of my workflow. When did the workflow start? What's the execution ID? There's more information than that, but essentially it's about the workflow execution itself. And this pink box here is one step in my workflow. And you can see there's some labels there. So each one of those labels represents a moment where I can transform the data within that step. This is what I mean. So if I want to access the input object, I use this $sign, and I can grab invoke an event by doing $.invoke an event. So that grabs this box here, which means I now reduce the data that's passed on to the next step, which is to call my AWS service, which is DynamoDB. Sorry, that's not the next step. It's the same step, but this is a kind of event within the step. So then I fetch something from DynamoDB, that returns a response, and in my response, I can make a new object based on that response, right? So I can say, I'm going to make something called status code, something called request ID, something called request date, and I'm going to grab that from this object. So that's in there somewhere. In there somewhere is these, right? I'm going to create my new object, and I'm going to pass that on, and then I'm going to add it to this. This is my next object. I'm still inside the state, and then finally I'm going to send that to my output path. And so basically what I've done here is I've transformed and combined the input payload with the result of my DynamoDB call into this nice new object, which will finally be passed on to the next state, and the process repeats again. Why is that important? Because going back to reducing cost, this is what I'm doing here. I'm affecting and changing and optimizing my data as it passes through my workflow. And if I'm using an Express workflow, that's how I reduce the memory allocation. That's how I reduce the duration of my workflow. So at every single step, I'm trying to tweak and reduce the costs here. The takeaway with cost regarding step functions is standard workflows reduce the number of states, Express workflow reduce the duration and the payload size. But then there's total cost. So all of that is just the cost of orchestrating all of those AWS services. This is some people's gripe about step functions is that it's just an orchestrator, I hear, right? It's just pulling other things together. And it is, but that's really damn useful. Here's some other things you can do with it though, right? A very simple workflow here. So the first thing this does is it gets something from a DynamoDB table. There's a cost associated with that in terms of my read capacity units. Then I have my first state transition. Cost associated. Then I invoke my Lambda function. So the Lambda service has a cost associated with that. Then there's my next state transition. Then I put something onto an event bridge event bus. So these are costs associated with running a service, and these are costs associated with the orchestration, with the step functions piece, right? So another thing you can do is you can reduce your reliance on various services. How do you do that? Intrinsic functions. So intrinsic functions are little helper functions within step functions that perform some simple operations. So things for manipulating arrays, manipulating JSON objects, strings, adding, subtracting. Let me show you what I mean. The most requested intrinsic function until recently was to generate a unique ID. So what people used to have to do was within their workflow, they would have to create a Lambda function that had some code to generate a unique string. And that might look like this. This is in Node. So here, I'm bringing in a library, some external library called the UUID library. I'm creating my exports handler. I'm running that library. I'm stringifying the response, and I'm returning that. This is how I can do it with intrinsics. I can just use the states UUID intrinsic function. And the reason that's good is because I don't have to have any Lambda cold start time. There's no invocation delays. There's no invocation costs. I've gone from 4 lines of code to 1. So there's lots of little places that you can do that when you're building with step functions, using intrinsics instead of Lambda to fill in the gaps on little pieces. I'm going to show this one more time because there's one more big cost optimization you can get out of this. And that's with this piece here. So here I'm polling a DynamoDB table. And we know now that every state transition costs me money and costs me time. That's actually another polling loop down here. So every time I go around this loop, I'm adding 3 transitions to my workflow cost. And that's because essentially what this is an asynchronous process, right? And asynchronous processes are, it's like real life. These happen all around us all the time. And when you're building applications, it looks like this. So you have a client that invokes service A. Service A returns a response or an acknowledgement, I should say. Say, okay, I got that. I'm going to go ahead and do that down here. You carry on, client. Then you have to retrieve that by some other means. And probably the most simplest way to understand when that thing is ready is by polling. And polling is really easy to implement. My daughter is really good at polling. She's 7 years old. Recently, I took her on a trip to France. We took the boat from New Haven, and I didn't realize it takes 5 hours. So we got on the boat, and as soon as we departed the port, she started asking me, Daddy, how long is it going to take? We're going to be there soon. I thought, oh, this is going to happen for the whole journey. And it did. She was continuously polling me for status updates until we got off the boat. Super effective. She really got real-time update about the journey, but really chatty, really expensive in terms of our happy day. This is what I would have preferred she'd done, right, is to use this callback method. And by the way, the reason I'm putting that up is because it's chatty with my daughter, but it's chatty with step functions as well. Every time you ask this question, it's costing you money. With the callback mechanism, this would be like me and my daughter getting on the boat, and she would go, hey, Dad, can you let me know when we're there? And I'd go, yeah, I'll let you know. Let's watch our phones for 5 hours. And we'd have a happier day, right? So you can do that with step functions. You can say, look, I'm going to stop here, as I'm the step functions now. I'm going to stop here, and I'm going to give you a special code. And when you give me back that code, I know it's you, and I'll carry on. And this is the next pattern I want to show you. It's called the callback pattern. And this is how it works, right? On this example, I'm putting a message onto an SNS topic. And along with that message, there's some text in red that says, wait for task token. It's like an added bit of syntax at the end of that call. By the way, this is states.sns.publish. So this is the SDK action, the API action that it's doing, right? I said there's 11,000 actions you can use with step functions. Well, this is one of them. If you look at the docs, you'll see all of these actions, and step functions has a task that is available to do each one. Okay, so along with this publish action, I put something called a task token. This is generated by the workflow service itself. It might look like that. And that's also thrown onto this topic. I'll store that task token somewhere because that task token is unique to this state. And this state will just wait there now until it hears back. And it will wait for up to 1 year. And you don't pay for the wait time. You pay for the state transitions, right? So then I use something like a Lambda function to throw back and say, here's your task token. You can carry on. This is the most powerful pattern I think I can show you when you're building with step functions. This is what Serverless Espresso is built on. This is what a new application we'll be showing next week is built on. This is something you can use in anything you're building, even if it's not serverless, if it's not on AWS, you can orchestrate other non-cloud microservices in this way with this emit and wait pattern. I nearly gave away a launch then. Okay, so this is what it does, and this is partnering up with EventBridge. So EventBridge is a service that is an event bus. All you do is you throw events onto your event bus, and then you write rules to take those events and route that onto another service. So that might be a Lambda function, for example. So here, I throw an event onto my event bus, and what I'm doing here is I'm managing a kind of conveyor belt of milestone important events where I need each one to happen sequentially, like ordering a cup of coffee, right? First you need the order, then you need the barista to accept the order, then you need the barista to say that they've completed the order, then you need to update the user. And each one of these things can only happen in that order. And we manage it with a workflow like this. So the first thing we do, milestone 1 we'll call it, we put milestone 1 along with any data that milestone 1 needs onto the event bus, and we route that event downstream to whatever microservice milestone 1 needs. And along with that, we get the task token. We store the task token somewhere, like in a DynamoDB table. And when my milestone 1 microservice is finished and ready, it grabs that task token and it gives it back to the workflow. And then the workflow goes on to milestone 2. And so the cycle continues, and it can wait for up to 1 year. But many things you don't want to wait for 1 year, right? So you can set a timeout or a heartbeat, and you say, look, I'm only prepared to wait 20 seconds for milestone 2. And if I don't hear back within 20 seconds, I'm going to call that an error. I'm going to catch that error, and I'm going to take a different route along my workflow. And so here, I'm able to call out to anything, essentially, inside and outside of AWS to orchestrate that using the power of my step functions workflows. So back to my e-commerce workflow, I'm going to strip out these 2 polling loops here, and I'm going to replace that by simply putting a wait task token on the step before them. And then we go back to our board. And we can look at the price now. So now I only got 8 state transitions. And the overall cost now has gone down further to just 20 cents. So I started at 42. Then I came in at 1 because I thought I could run this for just less than 5 minutes, but we found out we couldn't. And now we've managed to reduce that all the way back down to 20 cents for 1,000 executions. And I haven't even added intrinsics. There's lots and lots more things I could do, but for God's sake, let's move on and look at some other stuff, like managing failures. Managing failures. This handsome chap is Werner Vogels. He's the CTO of Amazon. He's a very big personality. And he's well known as having said that everything fails all the time. And step functions happens to be great for things that fail all the time. So here's a pattern called the saga pattern. It's a common pattern people talk about when building applications. And the idea here is that if you have a sequence of events that if one of them fails, you need to roll back in the same order, well, then you can use that built-in error catching of step functions to do that, right? So this is a holiday booking system. Here's my happy path. If my first state fails, then I can catch that and roll that back. If my first state succeeds and customer cancels or something fails, then I can have to catch that and roll both back. And so you have this nice kind of waterfall pattern, stepping up and stepping down, just by building in, by using the step functions catch mechanism. This one's called the circuit breaker. And so what this does is it stops you from calling a downstream service if you know it's broken and you don't want to keep requesting it because that might spin up some other cost or it might cause some other issue. So what we do here is we maintain the overall status of what we'll call our circuit, but it's really our application. And we maintain that in DynamoDB. And we say the first thing this workflow does is it checks, let's get the status of our circuit. So now we have the status, we pass that to the choice state. Is the status open or closed? If it's closed, that means everything's good. We can go ahead and we can do whatever we need to do. In this simple example, it's just calling a Lambda function. Then we exit. The next request comes in, it does the same thing, everything's good, but now my Lambda function fails. We capture the failure, we open the circuit, so the next request that comes in doesn't go ahead and try and invoke Lambda. Again, you're protecting those downstream services by using this orchestration tool. Yeah, this went out last week. Okay. Phew. So customer, this was a big request. I think it was the biggest request we had was if my workflow fails, until last week, you'd have to restart the entire workflow. And sometimes you'll have hundreds of steps before the one that failed. And if you restart the whole thing, it might take days, or you just have to incur the cost of going all the way through each one of those steps to get to the one that failed. Well, last week, we launched something called Redrive, which means you can just restart your workflow from that failed state. It's a very well-requested feature, I think, because it just saves people the time and the money from having to build something like that, build a hack for that themselves. Okay, is anyone building applications that need a lot of scale, a lot of requests in production already? No one? Oh, 1, 2, 3, 4. Okay, people just shy. Fair enough. So, step functions is incredible for building applications that need to run at vast scale, and without you really having to worry too much about when you have spiky traffic or when you need that scale. It will just be there, right? And I want to show you different ways you can do that. There's lots of different ways of running step functions concurrently. Now, the first is just to send lots of requests to the same workflow, and each one of those requests will spin up a new invocation of that workflow. If any one of them fails, it doesn't matter. They're like single-threaded processes. They won't affect the other workflows that are running. It will fail on its own. Then you have something called the parallel state. So this is a thing within step functions that lets you run multiple fixed branches all at the same time. So each one of the branches gets the same input. Once each one of them is finished running and produces an output, that output is sent to the next thing as an array. So you see here I have something that looks up an address. I don't know what address is 5, but something that looks up a phone number 1, and then they're added as an array to the final state together. Lovely. If one of those fails, well, the whole thing will fail unless you catch the failure, and then the failure is what's added to the final state. So the whole point of that is that you can run things at the same time within your workflow, right? Customers wanted a way to run things dynamically at the same time. So what I mean by that is to hand an array of items to my workflow, so not the same input, multiple different inputs, and allow my workflow to have a series of steps that can run concurrently. And so this is called dynamic parallelism. And this was introduced a couple of years ago in the form of something called the map state. And what this does is it allows you to kind of have a workflow within your workflow that can run concurrently. So here, I provide to this an array of items, and I can say either to run this map state for each item one at a time, or to run them all together. And so this starts to allow me to create some really interesting patterns as well, like the fan-out pattern. So this is a workflow that we built. We used a couple of years ago to create a website called serverlessland.com, which is a site, a really great resource for serverless, which aggregates all the different AWS blog posts into one website. And we built it using this workflow, or rather we populated the content using this workflow. And this is what runs every day. The first Lambda function uses an RSS feed to get a list of all the new blog posts that were published that day, an array. It sends that array to our map state, and then our map state will call out to another Lambda function to scrape some data, to get some metadata about each one of those blog posts. And then it will save each one of those metadata objects to GitHub. And when that's done, it will trigger a new build of our website. And this is what's running in production. It's been like that for the last 3 years or so. What we actually did recently is we improved it by converting it into the scatter gather, or the fan out and fan back in. So it's very similar. It's all the same steps. But this time, we create one big array of objects, and we move the GitHub save outside of the map state. Given everything I've been talking about, you can probably, hopefully, guess the reason, which is to save this from running multiple times inside here, right? If you just move it out, then we've probably saved ourselves maybe 15 Lambda invocations and 15 state transitions just by understanding how workflows are costed and dragging that outside of our map state. The problem is with the map state in that form is it only gives you a max concurrency of 40. So if you've got more than 40 items in your array, it will start to throttle and back off and handle that for you. So what customers were doing is they were embedding map states within map states within map states to get more and more concurrent executions. And so we said, okay, we'll just do it for you. And we last year at reInvent announced this thing called the distributed map state. So what this is it allows you to concurrently execute up to 10,000 items at a time. So we went from 40 to 10,000. And you can point this directly at an S3 bucket. And you can say, I want to run this on every item in my S3 bucket. Or you can point it at an object in your S3 bucket. And you can say, I want to run this concurrently for every row in my CSV file. You can do some cool things with it as well. You can still use the inline state. That old one of 40 concurrency still exists. Now, you know already what a standard and express workflow is, because we talked about that. So when you run a distributed map state, you can tell it to run as standard or express. You can even batch things up. This is what it looks like in the console. So you can see the percentage of failed executions within your map state. You can set an error threshold, and it gets very detailed and configurable. But the point is, you are achieving incredible concurrency by using this dynamic map state. It kind of runs as a separate workflow even. Here's an example, the best example I can think to explain the kind of scale that this gives you, right? So here's an application that I built last year as a demo at reInvent, which allows you to drop any MP4 file into an S3 bucket and generate a GIF animation for every 30 seconds of that MP4 file. And then that's loaded by this front end, which allows you to scrub across a kind of timeline. So you have a timeline scrubber for your MP4 file. This is how it works. You drop your file into S3. That starts the workflow with the name of the file and the name of the bucket. Then it uses a Lambda function with something called FFmpeg, which is a library for interacting with media files. And this FFmpeg library, first of all, says, okay, how long is this movie? It gets the length of the movie, and it says, if I need to make a GIF animation every 30 seconds, I'm going to create an object or an array of objects that says where each animation needs to start and finish. That's what these are two of those GIF animations as an array object. I'm going to save that array object to my S3 bucket, and then I'm going to put that in my distributed map state. And then I'm going to use a different Lambda function. And in this Lambda function, we'll be responsible for creating one GIF animation. And because each one of these GIF animation metadata objects are handed to my Lambda function at the same time, my Lambda function, boom, will burst out and scale out and run each one of them at exactly the same time. So the reason why that's incredible, for me at least, is because it doesn't matter if I'm doing a silly 5-second GIF animation from my house like this, or if I'm dropping in an 8-hour movie into S3, it will take about the same amount of time to complete because I'm splitting that up into multiple, up to 10,000 concurrent jobs just by using the power of this distributed map state. So again, this is probably the other super powerful pattern that I wanted to show you in terms of building for scale, understanding how you can break up workloads into multiple small pieces using Lambda, using step functions. So this is the place I would recommend to go next if you want to learn more about step functions or anything about serverless in general. It's s12d.com/workflows. This is Serverless Land, that website I mentioned earlier, right? It became more than just a blog aggregator. So here you have hundreds of workflows that have been uploaded and contributed by customers and by experts at AWS. Based on use case, based on service, you can find a workflow that's sort of similar to something you're building. You can look at the infrastructure as code template. You can look at the ASL definition, and you can even deploy that directly into your AWS account from that button. Okay, so we covered a lot. We talked about distributed map state for large-scale parallel processing. We talked about intrinsic functions. There were 14 new ones, but I think in total there's about 40 intrinsic functions. These are little helper functions in step functions that means you don't have to use Lambda for simple operations. We talked about why I think you should use step functions first when you build your next thing on AWS. We talked about the difference between standard and express workflows, when you would use one over the other, and the cost implementations of that. And we talked about path processing, how you manipulate and transform data as it moves through your state to save you money when you're building with express workflows. Serverless Espresso is not in the expo hall because we're not actually at reInvent. Maybe we could try that at another time. I could bring it in. It could be funny. And here's that final slide where you can dive deeper. Everything I've spoken about is written up here in more detail in various forms. So that's a very good resource for you as well. And of course, if you have more questions, I'm happy to come and chat to you. I'd love to chat to you, in fact. That's the whole point of me being here, really. And with that, I'll say thank you very much for your time. Thanks a lot.